Hello, 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 and welcome to Decentralized Podcast. My name is Pedro, and today I will be starting alone as Miguel is a little bit delayed due to work stuff. So, yeah, here we are for our live stream session of today, and um, today we will be live coding. So it will be a lot of fun. Um, but first, I have to say the usual stuff. Um, you just joined us in our mission to decentralize the world wisely. So grab a drink. I have my coffee. Sit back and relax as we can get really nerdy around here. So, um, and to keep us up to date with your presence in our live streams, press the like button whenever you can. Don't press it twice. Just one time is enough. Okay. And yeah, here we are on our session um, for starting our live coding. Okay. So let's start with our session. So first of all, I wanted to tell you guys that on the last session we created a bunch of rules for the smart contract, and those one of those rules was that the handles would have at least 3 characters, and they would have a maximum of 64. But as the usual um, integers in Solidity have 256 bits, it makes sense to have a limit of 32 so that we can pack an entire handle in just a single uint without much uh, bitwise operations and stuff like that. So in this idea, it's a lot simpler to pack it with general bytes and using ASCII codes, as simple as that, and in that way, each character would have 8 bits, and so 32 bits, 32 bytes would be the maximum, right? So yeah, this we changed this from our original idea that we talked yesterday, and I started already during these days implementing a few things. So I will probably share with you those things so that you get up and running with uh, with what I already did. It's not much, so it's just to let you know what is going on in the project. Uh, if you want, you can go to GitHub. Even after this live stream, everything that we are doing is uh, public on GitHub. So I created an organization for for this project, which is the handle, the dash handle. So if you go to github.com/the dash handle, you will have the repositories for this project. One of the repositories is docs, which is where we store our documentation, ideas, things that we will be writing for this project. And another one is contracts, and this is the repository that we will be watching today and working on. Okay, so let's go and check my screen. So here we are. You can see my screen, and you can see Miguel working as well. So he will join us in a bit. Here we are. We have, this is a generic Foundry project. Okay, so we have a soulbound abstract based contract, and we have a contract where we will be implementing the functions. Okay, so just a moment, please, as I have to just make a call. Just a moment. Okay, I'm back. Sorry, it was an urgent phone call. So yeah, we have here the contract that we will be working on, and this is a generic soulbound contract. So soulbound tokens usually are ERC 721 tokens, so NFTs, right? And they are impossible to transfer, or at least impossible to transfer the usual way that you use to transfer or to negotiate NFTs, which is putting them on a marketplace so that the marketplace can handle the sale for you, right? So in this, we can see that we are reverting on all these functions. So safe transfer from, transfer from, approve, set approval for all, get approved, and is approved for all. So this is the generic idea of a soul-bound NFT. Maybe we can do some improvements on this, but yeah, this is just a generic thing. And here is our contract, our the handle contract. So for minting our own tokens, right? So the idea is to have some way in this contract to mint new tokens and negotiate the new negotiate the tokens, do the auction, and so on. So it will be a little bit more complex than the usual NFT token. So the first thing that we have to do for an NFT is to call the constructor. Let me just get something here. So I will get the constructor ready to go. Yeah, we need to have the interface. Let me just get this here. This is not. There we are. And we need a constructor. Let's just assume that this is the way. Okay. There we are. So no errors anymore. Perfect. Let's see if this thing builds. What do we have? Counter.sol not found. Where is this? This is the testing thing. Yeah. Let's just move this. This is standard testing stuff. We'll just keep it there as that. It's just an empty test. So what do we have? Safe transfer from is virtual. Okay. So let's see. Safe transfer from. Non-virtual. Okay. So probably this is not needed. Is missing the override. Okay. So this is an interesting thing. Let's see if this builds. Live coding is always so much fun. So this should work. Why it's not working? No idea. Now everything is okay. And the compilation is not working. Let's see if we build it in another way. Compile contract. If you guys spot the problem, let us know in the chat. I am trying to figure out. So non-virtual function. Let's see what's happening here. ERC721. Okay. Let's see what's here. Yeah, safe transfer from is not virtual. But this is from Open Zeppelin. So Open Zeppelin contracts are standard contracts. So this shouldn't be changed, right? So let me just check one thing. So contracts, token. Yeah, it should be some problem with the versions. Yeah, because it seems that should be an older version. Let me check. Don't run away. Stay with us. This is hard stuff, but we will eventually get it done. You just have to be patient. You have to be patient to be a developer anyway, right? So keep on grinding. That's the way it is. So let me check one thing. So it seems that the problem here is that the version that I have installed in the project somehow doesn't have the functions over virtual, so they cannot be overridden. And I don't know why. I am checking why they don't have the virtual keyword on those functions, because they should, I think, be virtual. So let me check. That's what I'm doing right now. Yeah, the version that we have online for Open Zeppelin contracts is it has the virtual keyword. So the latest version. Let's see what's happening here. So if we go to the ERC20 Open Zeppelin contracts, last updated version 5. Really? Let me check this. Seems a little bit strange. Version 5 seems a little bit strange. No, it's 5 actually. Yeah, the latest one. Okay. So virtual. Transfer from is virtual. Safe transfer from is not virtual. This one, but this one is virtual. So this can be the problem. So we cannot override this one because this one delegates to this one. And we can only override this one and we're good to go. So it seems to be a plausible solution for this. So let me see. Transfer from bytes memory, transfer from without. So this should be the problematic one. Let's check. Unreachable codes. Okay. This is a warning, not a problem. And we're good to go. So this was the problem. So you see, This function cannot be overridden because it's just a proxy function defined on the ERC20, the ERC71 standard in OpenZeppelin. Okay. And so by overriding this function, we do it all because this one calls this one. So it's a natural thing. Probably this was virtual once in time, and then they upgraded it so that it doesn't make sense to be virtual. So it's okay. Now we have some other code that is not going, not reachable because this is not done yet. So that's natural. So now we have our project good to go to start our journey. So first of all, what do we need here? So let me just check. So we need some way to store our token holders. So this can be like mapping, right? Do we have Miguel already?
Yeah, give me a moment. Let me prepare.
It seems that we are getting the help of Miguel, which is a lot better. Let's see.
And here we go.
Oh yeah.
So hello guys, everybody. Hope you're enjoying Pedro's tutorial.
This has been more of a trying to find a problem session, and yeah, it's done.
So please put me in the loop. Oh, what's going on?
The code that I grabbed from for a soulbound token adds two overrides for the safe transfer from. One, there are two versions of this function on the ERC721. One is with bytes memory and the other without.
Mm-hmm.
And the without calls the one that has the full parameter list. So the guys from OpenZeppelin naturally on the last version they have the function with less parameters non-virtual because it's just a proxy to this function, and if you override this function, that's okay.
Yep.
Right. And that should be changed. Should have changed in the last few versions, and this code was not yet taking that into account, so it was overriding both functions.
Okay.
And I removed the other one, and it's good to go.
Mhm.
But I had to go through the versions and stuff like that to find why it was not being virtual. And yeah, that has been the nightmare of this session until now.
Yeah, it's no nightmare. It's just
It's
what it is.
the usual thing
Yeah.
for developers, right?
Yeah,
Especially
exactly.
when we are doing live coding. So the gods of live coding are very active usually.
No, it's usually witchcraft. You just need to get used to it.
I don't believe.
Yeah, right.
I don't believe in witches, but they exist.
Yeah,
So it happens.
they're around.
So yeah, so we have this contract, soulbound, which makes all these functions unusable, the base stuff, and we are starting on this contract. I just have a constructor with the token contract name, a simple one, and I was starting to make some storage stuff. So
Okay.
what I was saying was that we need to have a mapping. So a mapping from uint to 56 onto what do we need to store here? One address, right?
Yeah,
It's the owner.
but it's an address or an IPFS address.
Not sure. Well, okay, we need to have an address. This is the owners. What's the name? Let's where the tokens are stored. So let me check.
Okay, so we will probably need a structure then.
We can have just owners. Or we can have underscore owners, so that is the standard of calling of naming storage variables for whatever reason. I don't know, but let's accept that. So this maps the owners. So, and we need to have the metadata and the address and stuff like that, the URLs for this token.
Yeah, that's why I was saying instead of storing an address, we could store a structure with the necessary data.
Yes. But there is already the URL or URI that is already part of the standard of ERC 721.
Yeah, that is correct.
And I'm not sure how it is implemented. So let me...
it's a JSON, if I'm not mistaken. with a specific format. Let me check.
Yeah, open Zeppelin's ERC 721 documentation. So there is an ERC 721 metadata. Which has a base URI.
Yeah, I remember it has a specific format.
Yeah, that was my idea. Extensions, metadata. So token URI, you pass the token ID and you get the string associated with that token ID.
Mm-hmm.
And that's it.
Yeah, I think it's the only thing. Yeah, and you even have function for that.
Yeah.
Yeah.
So
on the metadata, you have the name, symbol, and token URI.
Yeah. So that is already done. We don't have to store that data.
Exactly. Yeah.
So the only thing that we need to store is the owners. And let me check one another thing, because this is already there. Let me check on the standard contract. Yeah, it's already there as well. So we don't even need this here because it's already on the standard contract.
Does that contract already has all the extensions?
Not the metadata. I think the metadata has. Oh yeah, there is a metadata. Yes. So the standard contract ERC 721 already holds that metadata. The only thing that we need extra, I think, is the enumeration stuff that we need to figure out how to put. Let's check. Enumeration extension enumerable. So that has owned tokens mapping from owner to mapping of index to ID, and has a token a mapping of own tokens index as well.
Yeah, it has 3 new functions. One is the token supply, token of owner by index, and the token by index. So these three functions will make it enumerable.
Yeah. So we need to figure out if we need this at all or not. Because we will have to somehow be able to go through the list of tokens.
Yes. Yes,
For
because
instance,
we need to check, for instance, if it already exists.
that's
for
an
one.
easy one.
Yeah,
That's
but you need to enumerate.
No, you don't. You just go through the map, go to the mapping, and pass the token ID because you say you know the token ID beforehand.
No, you don't.
Yes,
That's
of
what I'm
course.
saying. If you want to create a new identity with a name that already exists,
It will fail because the mapping already has that ID. Because don't forget that the ID is
right?
computed
It's a compilation of
by the
the
name
string.
of that we are registering.
I got it.
So you just check it, and if it holds something other than address 0, it means that it's already owned, right?
Yeah.
So we don't need that. But the enumeration that I think that we will need will be on the side of the marketplace. We need to have a way to know which tokens are in auction, right? And which tokens are
Does the smart contract need to know that?
yes, because it has to be done in the smart contract. We will implement the auction process in the smart contract.
That's not what I'm saying. Where I'm getting at is you are saying that you need to show which NFTs are
For auction.
available for auction.
Yeah, because the
And
marketplace.
you can't just get all of the identities and check them in the front end. So you don't need to go through them in the smart contract.
No, in the smart contract side, no. But on the application side for the marketplaces, the marketplaces need to have a way to have all tokens that are going through an auction so that they can display them and they can accept offers on behalf of users and make the bids on the contract. Right?
I'm thinking. Because if the front end just gets all NFTs, it can do whatever filtering it wants.
Yeah, but getting all NFTs is a tricky thing. Usually, we need to understand if we are doing it the proper way or not. So I would suggest that we keep this in our to-do list for now.
Yeah. There is another thing that I would like to ask you. If we are going to be capable to just delete an identity so that we have or not to implement a burnable extension.
Yeah, just the owner can burn their own tokens. That is the idea, but it's not a burn in itself. It's more like a unregister
I would just delete the NFT.
Yeah, it will do the burn, but the problem is that it has to return the stake, right?
Exactly. Yeah.
So the owner says,
the
I am not
burnable.
interested anymore, and I want my stake back, and that's it.
Well, the burn function can take care of that.
We can call it burn, but I would prefer to find a new name for that, because burn usually implies destruction of the thing without getting anything back. So that might be misleading for the users of the smart contract and for the developers of the marketplaces.
But we have an interface for that, and we should stick to the standards.
I know, but if we are implementing different stuff on an interface, that creates a problem. That's why we don't need to have a burn in the contract.
We do, because we will burn the NFT.
We will burn the NFT, but inside another function. The interface of the smart contract, the RC721 has an internal burn, but I don't think the burn function is from the public interface. You can have it, but you don't have to, I think.
I don't see it. It makes sense to use the burn function. Why not? I know that you're figuring that it's doing something else other than just burn, but it's the behavior of the NFT. When it burns, it has to return the stake. So I don't know. It just makes sense because it's the intrinsic behavior.
Yeah, but it's a question of naming, not. For instance, when you burn an ERC20 token, you effectively lose that value. Okay, the idea of burning is not getting anything in return, is trashing something completely. Okay, so if we would have a function to completely burn the stake and the NFT, I would agree that the burn name would be the correct one. But since we are returning the stake, I think the burn is not the ideal, and we don't have to have that function. We can call it something else.
Let me suggest something, because if we are implementing that function, it will make available certain behaviors on usage, either on other contracts or front ends, wallets, whatever. So those pieces of software will just try to figure out if it's burnable or not, and will make available that functionality. Right?
Yeah, so, I
know. It's the same for the metadata. A wallet can use the metadata functions, right? And that's why we are making it available. So if we can make available the burn method to a wallet so that we can burn the token and get the stake back, I think it's a free functionality that we have.
Okay, but do we want to confuse the users of that specific wallet in doing a burn or not doing a burn because they have stake in the token and they are afraid of losing it?
Yeah, how else would they burn?
That is my issue with the
So
burn.
we can make that functionality available in the markets.
Yeah, it's
But if we also have it in the wallet, well, the user might be scared to use it and go to the market. But somebody that is not scared to use it, it will just burn it and that's it. So we just make it available for usage. It will function properly, so the user won't get burned. But if the user doesn't know exactly if he's going to get his stake back, he can go to the market and burn it with proper text.
Yeah, that can be one way. We can have a burn function, and return.
It can even be encapsulating the burn and get stake back function.
I know.
Right. Yeah.
Okay, but let's not just be so picky on the names. Yeah, that is a very good thing. Don't get me wrong. We should have we should be much careful with the names that we call things. That's
yeah, I do understand.
Especially on smart contracts, because they can be used through an interface or directly, and people should know what they're doing unless they want to be miserable by losing all their funds.
Yeah.
And so now I have another problem, which is
we are here to solve problems.
Of course we are. That's what we do, right? But the problem that I have is, well, we have the URL, the URL of the token. That URL usually points to IPFS or something like that.
Yes.
But there are a few standards on that. Some tokens point directly to the JPEG on IPFS. Some other tokens have some kind of structure. Are you aware of any standards of these?
I don't think there's a standard.
I'm sure there is not an official standard, but there should be some best practices so that wallets that show NFTs are able to show them.
No, they just usually when they have an NFT, it's usually an image, so it's just a URL to an image, and it's usually not even IPFS. Usually, people just use an HTTP.
Yeah, that is the kind of craziness that people without any knowledge of decentralization do. Yeah. But the regular people that know what they're doing usually point to IPFS and grab some unlimited storage for that content.
You can put whatever URL you want. Of course, we are going to use IPFS. It's different since the beginning. But regarding having a structure inside your IPFS, we can do whatever we want.
Yeah, no, but that
I
will
have
break
never
the
seen
wallets.
anything.
That will prevent the wallets from showing our NFTs, and we don't want that. Right?
Right.
What we want is to send them some kind of SVG image of the token ID. That would be cool, but I really think that will be very costly to do on Solidity. I'm not sure. Imagine if you get the URI, and the URI that you return is an SVG that has the some, or it can be a PNG that we generate and put on IPFS. It's much easier than that. So my idea would be, I am at my wallet, I have my NFTs, and I see this NFT as a graphic image with its name. So I own the PRC handle. So I see some kind of graphic around and PRC in the center, so that people understand. I could identify PRC from other handles that I might own.
Okay.
On the wallet itself.
Check this out. The metadata in ERC 721 has several stuff inside.
Mm-hmm.
So you have a title, an object type, and you have some properties. In the properties, you have a name, a description, and an image. So I think we can.
Where are you seeing that?
There is this eips.ethereum.org. I'll send you the link.
No, but I want. Is it on somehow on Open Zeppelin contracts that we can check the Solidity code?
Maybe let me check.
Because here it's just a URI. I cannot find anything related to.
Yeah, I don't have the implementation here. Do you know how to find the implementation?
Let me check. So I see
the token URI. It's just getting.
So the metadata JSON schema is what is returned from the URI that you return. So this is the standard. Good.
Sorry, can you repeat that?
So the idea of this URI that is returned by the function token URI, you pass it the token ID and you get a URI where that you can do a get. And by getting that URI, what you will get back as a result on the web should be this structure that you were saying. The ERC 721 metadata JSON schema.
So this is the string that it's stored. It has this structure.
No, this is the result of the URI that you get from the token URI function. Let me read you this. The URI may point to a JSON file that conforms to the ERC721 metadata JSON schema.
Okay.
So may point, not have to, but this is a standard, so that if you want to comply with this, you should. I am pretty positive that most wallets will test if it returns an image. They just use the image. If it returns a JSON, they assume this is the standard, right?
Yeah.
Okay.
And it can probably, the JSON can probably have some more data, but this is what's specified.
Yeah, this is the standard things, but you can return more for sure.
Yeah.
We need to investigate that anyway.
More data, if we need to store more metadata, we can use this file.
Yeah. So it has a name, a description, and an image.
Yep.
And okay, I'm not sure about this type object.
Yeah, well,
strange.
Yeah, because it seems
it's
to be
type string.
Fixed.
Type string. So description has a type string and then description.
Yeah. But this is all very strict, so I'm not sure why they are specifying the type. Type object is because properties is an object.
Yeah, this is a schema, not a JSON object. Okay, so it says that it should have these properties.
Yeah, right? Exactly. Yeah, this is
name, which is a string, a description, which is a string, and an image, which is a string.
I was also reading it as an example.
Yeah, fuck it. Yeah. Oh, I cannot say this. We are live. Fuck it.
You can't.
Well, guys, I really think that we are very, very late already. I'm sorry, this was not a fun one. We were most of the time
making decisions and
trying to figure out
stuff.
But we are working on an hackathon. We are hacking, so this is the way to do it. So yeah, we will continue this, and hopefully on the next episode we will have more to show you and more productive conversation. Let's see.
Yeah.
Anyway, I hope you enjoyed hacking with us. If you do, press the like button. Not twice, just once. It's enough. Okay.
Yeah, but you
don't do it.
Enough. You
only
can
one.
Smash it.
Only one time. Don't do it more than one. And subscribe if you want to join us on all episodes that we are doing this, and
reach us on our social media. We have the links. We provide you the links so that you can get to us, send us messages, questions. However you want to interact with us, we will try to reply as soon as possible.
Yeah, you can join our Telegram. It's on our website. You just check there. There's links for our socials as well on the description of this video. And just join us and say hi. That's a good start. And yeah, hopefully on Friday we will have a lot more done, and we will go through the code that we did behind the scenes and continue further testing stuff and building with all of you with us. So enjoy your
Till then.
Thursday, and until Friday, hope you will join us again. Thank you for joining us in our mission to decentralize the world wisely. And we'll see you in the next episode. Cheers.
In the next round, guys.
Bye-bye.